Okay, today for lesson 11, we are looking again at graphs of proportional relationships. Now we're going to be interpreting graphs, so we're understanding the information that's being shown in them. So we're going to be looking at the points or the line on the graph to find that information. That will tell us what the constant of proportionality is. And using that single point is going to be crucial in figuring that information out. Now, we could create an equation or a table from that information. Primarily, though, we're going to be looking at the actual graph. Our first question wants us to take a look at this graph representing a proportional relationship. Now, from what we learned yesterday, we don't need to be told that it's representing a proportional relationship. Because remember, there's two requirements for a graph to be representing a proportional relationship. It has to be a straight line. All the data has to be in a straight line, and it must connect at the origin, that 0, 0 point. We have both of those going on here, so we know it's a proportional relationship. But now what we're going to do, since there are no labels on each axis, there's no title, there's no other information given except for this line, and I can see one point filled in, and that point is at 16 on the x-axis, 12 on the y-axis. So I need to use that point to kind of describe my situation. Right now I'm kind of hungry, so I'm thinking, let's say that it costs $12 for 16 burritos. So burritos and cost. All right, we label the axis with the quantities that we're talking about. We're going to pick a point on the graph, which is already identified for us, and describe what it represents in your situation. So if I were to extend that location, the 16, remember, is my x value. So 16 burritos cost $12. And that would describe my situation here in the graph. Now, you could certainly do something else. You don't have to do my example if you want to come up with something a little bit different. For the next activity, we're going to be looking at Tyler's walk, and it says he's at an amusement park. He's walking at a steady pace. Now, you have this in your handout. I don't have it all copied on my screen for you, so please follow along with me in the weekly packet. But it says he walked at a steady pace. Now, that is really important because steady pace is like a constant speed. He's not speeding up or slowing down, because if he was stopping, that's going to not be a proportional relationship. Because it's a steady pace, it will be a proportional relationship. And he's going from the ticket booth to the bumper cars. It says the point on the graph shows his arrival at the bumper cars. So this is his arrival at the bumper cars. Now, there's several questions that we need to look at. First, it wants to know what the coordinates of the point tell us about the situation. So we are told this is his arrival at the bumper cars. If we extend it to the x and the y axis, and we can look at the labels here closely, we can see if we go to the x-axis, that is time in seconds. If we go to the y-axis, that is the distance from the ticket booth in meters. So using that information, we can see that he reached the bumper cars 40 seconds after leaving the ticket booth, and that the bumper cars are 50 meters away from the ticket booth. Now, the second part B, says the table represents Tyler's walk, and it shows the values of time and distance. Complete the table. Most of that is done for us. You can see one missing part here, and it's connected to 1 second of time. So I can see our point that's already there on the graph and several other points We know 0, 0 has got to be a point because that's the origin of the graph. And if it's a proportional relationship, this must be a point in our data. But 1 second, we want to see what distance he has traveled. That's going to be a unit rate. That's going to be giving us our constant of proportionality. That's a very important ratio in this situation, in this proportional relationship. So remember, to find the unit rate, to find the constant of proportionality, we can take any of our y values and divide it by the corresponding x value. I could divide 50 by 40, 37.5 by 30, 25 by 20, and 0, 0 isn't going to help me find that constant of proportionality, but any of these 3 points would. I'm going to pick one. I'm going to pick 50 and 40 since that was the point we were given here initially. If I divide 50 by 40 and simplify that, I would get the point 1.25. Okay, and again, that's my unit rate. So the question asks us to complete the table. Now it's going to ask us to kind of evaluate what this information means. First, we're going to put the plot of pairs of values onto the graph. So these points here are all going to be part of my graph. This one is going to be easy to plot because they're nice even numbers, which line up with the markings here on the sides on the X and Y axis and their intervals. So I can see that my time is going up by 5-second markings here, and so is my distance in meters. So I have the same interval there. So let's put, well, first 0, 0, the origin, then 20 seconds and 25 meters. So I'll go on the x-axis to 20 seconds, up to 25 meters, and make a point. Now 30 and 37.5 are also going to be on there. Now the 37.5 I'm going to have to kind of estimate because I'm not given smaller markings between here. I'm only going up by 5 measurement units. So I'm going to have to kind of estimate about where that would be, and then 40, 50 is marked for me. Now, since I know it's a proportional relationship, since it's a straight line, if I had a straight edge, this would be really easy. But I know it's going to go from the origin and connect to all of those points and continue on. So that point 30 seconds and 37.5 meters, I'm actually going to make after I draw the line and kept it as straight as I could. I know it's going to be on that line, and it's going to be the same with this unit rate. Finding 1 second and 1.25 meters is going to be right here, almost at the origin of the graph, because our intervals are so much larger than that. So I drew my line first, and now I'm going to make that point of 1 and 1.25. Okay, that was part C. Part D says, what does the point 0, 0 mean in this situation? Well, remember, this is where the bumper cars were. This is where Tyler reached the bumper cars, and this is representing his distance from the ticket booth to the bumper cars. So point 0, 0 must be the ticket booth. Part E says, how far away from the ticket booth was Tyler after 1 second? Now that would be difficult to tell here on the graph. What we would need to use is what we did here in the table. We would use a ratio or a point that we're given to figure out that unit rate. After 1 second's time, he went 1.25 meters. All right, it says label the point on the graph that shows that information. So the best way to do that would be the same way that this point was shown on the graph, the 40, 50. I would write that here as 1 and 1.25. For part F, what is the constant of proportionality for the relationship between time and distance? We've already figured this out. A lot of this is very repetitive information. We knew that right here in the table when we found our unit rate. So our constant of proportionality is 1.25. We can also see that here on this first point of our graph. Part G says, what does it tell you about Tyler's walk? All we need to do now is compare this point that we were just talking about, this constant of proportionality, to how it's labeled here on the graph. So Tyler walks a distance of 1.25 meters every second. That would be his speed. And remember, it's a steady pace, a constant speed, so that's not going to be changing. And that's seen here at this point. We could also, just as a quick review of yesterday, we can make an equation for this. So if we're following that format of y equals k times x, our k value we've known for a while is 1.25 times x. Our x is our time. Our x is our time, and our distance is our y value. So if I use this equation, I could take any time in seconds and multiply it by our constant of proportionality to figure out how far he had gone. Let's look at another activity. All right, today is a good day to be glad you're not a seagull, because four seagulls ate 10 pounds of garbage. Assume this information describes a proportional relationship. Now let's go through the steps here. Let's complete the graph to answer our questions and continue on. We know we've got a proportional relationship, so our graph is going to have a straight line connected at the origin here. And if we look at the first part, it says plot a point that shows the number of seagulls and the amount of garbage they ate. We were told that point. It's right there. 4 seagulls ate 10 pounds of garbage. So now we just need to be aware of how our graph is labeled. The number of seagulls is here on the x-axis. So I need to go to 4, being the number of seagulls, and then up to 10 pounds of garbage. And that is going to represent my data point here. I could also label that just to be a little more clear. All right, that takes care of part A. Part B, draw a line through this point and 0, 0, the origin. All right, we know it's a proportional relationship, so we'll connect the origin to that point as best we can, as straight a line as we can make. And now, any point along this line, if it was drawn perfectly straight, would also represent how much garbage different amounts of seagulls would eat. So we've done part B. Part C says plot the point 1, k on the line. Remember what that variable k is representing in our proportional relationship. It's our constant of proportionality. So we need to find our constant of proportionality. I can kind of guess, just by looking at the line I drew, that based on 1 seagull, it's going to eat between 2 and 3 pounds of garbage. But because my line isn't perfect, I can't just guess at that, okay? So I know my point is going to be here where it connects to that proportional relationship line, but I want to calculate that exactly. All right, so to find the k value, we can always take our y and x locations of our ordered pair. We can take our y quantity and divide it by our x quantity, just like we were doing in tables, to find that constant of proportionality. So the point that I know is a y quantity of 10 pounds of garbage divided by 4 seagulls. That's my k value. That's my constant of proportionality. And this might be good to simplify a little further. We could keep it as 10/4, but that's a lot harder to identify as a point here on a graph. So let's divide 10 by 4, and that equals 2.5. So right there, I've just identified that one seagull eats 2.5 pounds of garbage. This is my constant of proportionality, my K value, and that is my first point here on the graph. That's my unit rate. All right, so we just described part D as well. What is the value of K? 1.25, the constant of proportionality here. How do I know? Well, I know that by using the information, the ratio given, I've calculated that constant of proportionality. And then lastly, what does the value of K tell you about this context? Again, we said that one seagull eats 2.5 pounds of garbage. Okay, last activity. Filling a bucket. Water runs from a hose into a bucket at a steady rate. The amount of water in the bucket for the time it is being filled is shown in the graph. The point 12.5 is on the graph, and I can see that here at the end of the line. What do the coordinates, what does this ordered pair tell you about the water in the bucket? So all I have to do is take this point and see what it represents on each axis. So at 5, that's 5 gallons of water, and at 12, that is the time in seconds. So when the question asks, what is that ordered pair, what does that point tell us about the water in the bucket? There's 5 gallons of water in the bucket after 12 seconds. That water's coming out pretty fast. Part B says, how many gallons of water were in the bucket after 1 second? What's that unit rate? So in 1 second's time, how many gallons of water are leaving the faucet? Now here's where I would do a little estimating to make sure that I don't make a mistake. If I want to know after 1 second, that's here on the x-axis. And I can see that my amount of water is going to be less than 1 gallon. So when I'm calculating, I want to confirm that I get less than 1 gallon of water as my answer to this. So remember, we can always find the unit rate, the constant of proportionality, by taking y divided by x. Let's take our y value from our ordered pair here, from our graph. Our y value is 5. So 5 divided by 12 is going to give me that constant of proportionality. Now, we can actually divide that and get a decimal if we want. 5 divided by 12 is equal to 0.4, which just makes it a little bit easier to label on the graph, because what we're going to do is label that point on the graph to show the information. Here at that point, we have 1 second's time and 0.4 gallons of water entering the bucket. Okay, that's today's lesson. That is interpreting these graphs of proportional relationships. Remember, a couple really important things is that we can always divide the y quantity on a graph or a point on a graph by its corresponding x quantity to get the constant of proportionality, to get the unit rates. Remember, a proportional relationship always has to have a straight line that's connected to the origin. So keep those in mind as you look at today's practice problems, and we'll be back with lesson 12.